Good morning. Today we're going to deal with a problem having to do with energy. I'm Gabriel, and this is Physics with the Experts. Here's our problem. A workman holds a 5-kilogram box on top of a 30-meter platform and releases his grip. What is the speed of the box when it has fallen halfway to the ground? Second part. If instead it had been a 10-kilogram box, what would the box's new speed have been, and how would the kinetic energies compare? Alright. So as with any physics problem, let's start by drawing a sketch. So here we are. We start with the box on top of a 30-meter platform, and as it falls, we get to 15 meters in height. Now, let's write the general equation. We'll be using energy methods. The sum of the initial energies equals the sum of the final energies. Because it's a closed system, we'll assume there's no air resistance. This is the law of conservation of energy. Then we'll fill in our variables and solve. Expanding this conservation of energy equation into potential and kinetic parts, we get initial potential plus initial kinetic equals final potential plus final kinetic. Substituting in our formulas for potential and kinetic energies, we get mgh initial, the initial height times the mass, times g, equals 1/2 mv initial squared, equals mgh final plus 1/2 mv final squared. So now we have the law of conservation of energy written out and expanded so that we can start to plug in and rearrange quantities. Now, because m appears in each of the terms in this equation, we'll divide it out to make our math a little bit easier. Here we are, the same equation now without any mass in it. Now we're going to subtract g h sub f over, because what we're going to solve for is v final after having fallen 15 meters. Here's what we get after having subtracted. Then we multiply by 2 and square root, giving us this expression here. Simplifying further, we get v final equals 2, and now substituting in, g is 10, initial height 30, as the problem states, plus 1/2 v initial, 0, it starts from rest, he just releases it from his grip, minus g h final. The final height would be 15 meters. G is 10 for this problem. Now, let's go ahead and simplify that expression a little bit. V final equals 2 times, 10 times 30 would be 300. This term is 0, and this term is 10 times 15, which is 150. 2 times 300 minus 150 gives us 2 times 150, or 300 inside the radical, giving us an approximate answer of 17.32 meters per second. So now we've found the velocity after it's fallen 15 meters. That's the first part of the problem. Now let's move on to tackle the second part of the problem. Now, from kinematics, we have the equation delta V equals A delta T, with no m dependence whatsoever. Meaning, if the delta T's are the same, the delta V's are the same. Now remember, it takes all objects, regardless of mass, if you ignore air resistance, the same amount of time to fall the same amount of distance. So if we take our 10-kilogram box now, and see how long it takes to fall 15 meters, in the same way that we took our 5-kilogram box to see how long it took to fall 15 meters, the delta T's are the same. Meaning, the velocities at the bottom of the 15-meter fall are going to be the same. So we've already started to do the first question in part 2. We found that the delta V's are the same if they both started from 0 meters per second. They've now ended up both at 17.32 meters per second. So we have now found the velocity of the 10-kilogram box. And this makes intuitive sense. If all things take the same amount of time to fall the same distance, they should have the same velocities at every point through flight. Comes from physical intuition. Last, we'll use our equation for the kinetic energy. Kinetic energy, as you know, is equal to 1/2 mv squared. The kinetic energy of the 5-kilogram box is 1/2 times 5 its mass times its velocity squared. The kinetic energy of the 10-kilogram box is 1/2 times 10 its mass times its velocity squared. Taking our ratio, using the expressions, 1/2 of 10 v squared would be 5v squared, and 1/2 of 5v squared would be 2.5v squared. We find that their ratios the ratio between the two is 2. Meaning the kinetic energy in the 10 kilogram box is twice as great. This makes intuitive sense if you have two objects moving at the same speed. Because kinetic energy is proportional to mass, then the one with twice the mass should have twice the kinetic energy. There we've solved both parts of the problem, and the problem is done. Thank you for watching.